Now, if an object is attached with a string or a wire, what are the forces acting on this object? If it was at rest or moving at a constant speed, so the forces which are acting, the weight is acting downward and tension is acting upward with reference to this object. But as I mentioned, the direction of the tension is always to pull. But if I talk about this point, what are the forces? So the tension will point downward to pull this point, and there will be a force, the attachment force is there, or a contact force is there, because this part of a string, two things are there. One is the string and then the object. So if I say draw an arrow, draw a free body force diagram to represent the forces acting on the sphere or an object, so its weight is acting downward, and because it is stationary, so tension is to pull. But if I say draw an arrow to show the forces acting at a point of contact, so what are the forces acting on the point of contact? That in this case, the tension will be downward and the normal contact force or the point of contact force will be upward. So the direction of the tension is not fixed. It changes according to the object which you consider. So if I have another example, if two objects are attached, one is 8 kilogram, another one is 2 kilogram. So this is object 1. This is object 1 and this is object 2. So if you want to write, and both are stationary at rest. If you want to write the forces for object 1, so what are the forces acting on the object 1? The weight of object 1 is acting downward and the tension is there. Here, why we write T1 and T2 and here we wrote only T, because this only one string was there. If only one string the object is attached, so the magnitude of a tension here will be same as the magnitude of tension here. But in this case, why we wrote T1 and T2? Because the two tensions will not be same. So the first one, if you take this object, so its weight is acting downward and the tension 1 is acting upward. So we can say T1 minus W is equals to 0, or we can say T1 is equals to W. And W is equals to mg, so mass multiplied by gravity. So we got 19.6 newtons. So the value of the T1 is how much? The value of the T1 is 19.6 Newton. But if we want to write an equation for overall, like we want to write equation for this T2. So if we want to write equation for T2, then we have to consider these two objects as one. Because if I want to write equation for T2, these two objects, I will consider them as 1. So if I consider these two objects as 1, what are the total force acting? The weight of this object, which was 19.6 newtons, which was acting downward, and weight of the second object, which was 8 into 19.6, that is also acting downward. 8 into 9.8, which is also acting downward. So the two forces are acting downward, and that is balances with the T2. So T2 will be equals to the sum of 19.6 plus 8 into 9.81, which is 98.1. So the tension in this rope will be higher. Why the tension in this rope is higher? Because it is holding the two objects. But the tension in the lower rope is lower. Why? Because it is only holding. Yeah, there will be attachment force. The attachment force, if I consider this point, there will be attachment force here, but what we are doing, we are not considering, we're considering like first an object alone and then the objects together. Is it clear, this example? Any doubt in this? Now, what if the two objects are attached by a pulley and M1 and M2 are the two masses? The first mass is accelerating up The first mass is accelerating up and the second mass is accelerating down. And we want to find the relation between them. So if I want to write an equation for the first mass, because it is accelerating up, so I can say T minus W1 is equals to MA. If I want to write the equation for the second mass, because it is accelerating downwards, so if it is accelerating downward, W2 minus T is equals to MA. They both have the same acceleration, like the acceleration of M1 is same as the acceleration of M2. So if I want to write an equation for A, like we can derive a formula for A or we can derive a formula for tensions. So if I want to, so right now we are not discussing the full equation, we are just deriving the equation for single motion. This is because in this example, all the complete equations are written, but the important thing is you should be able to form the independent equation for each motion. So this object, a mass attached with a pulley, two masses are there. One is accelerating upward, another one is accelerating downward. So if I want to write the equation for the first mass, so T minus W1 is equals to MA. Why I wrote T first? Why I wrote T first? Because the T is greater than W1, that's why it is accelerating upward. But if I want to write the equation for the second one, I will write W2 minus T is equals to M2A. Why M2A? Because according to Newton's second law, resultant force is always mass into acceleration. Mass of the second object is M2 and the mass of the first object is M1. So here the resultant force will be M1A and here the resultant force is M2A. If I want to write the equation, combined equation for acceleration, what I can do, I can add them. If I add the two equations, this will cancel with this. So I can say W2 minus W1 is equals to M1A plus M2A. And W2 will be equals to M2G. My W1 is equals to M1G. If I take M common, so it will be M1 plus M2 into A. This is multiplied, other side will be divided. If I take G common, so this will be M2 minus M1 into G divided by M1 plus M2. That is equals to A. So this is a direct formula. If two objects are attached with a string or a wire and they are accelerating and I need the acceleration, so what I can do, I can use this direct formula. But as I mentioned, I don't advise students to learn the formulas in physics. Try to understand the concepts, that you should be able to write the half equations, and from the half equations you can work out the acceleration. Just add the two equations after substituting the values and you will work the acceleration instead of memorizing a formula. Is it clear, this one? Is it clear, this example about the tension?
Yes, sir.
Any question or doubt till this point?
No, sir.
Yeah, sure, I will explain the equations again. See, important thing is how to observe the motion. Like observing a motion, this object was accelerating up and this object is accelerating down. Now if an object is accelerating up, it means the tension is more than the weight. So I can say T minus W1 is equals to M, resultant force is equals to MA. But what is M here? Because we are finding resultant force on M1, that's why we put M1A. Same thing, the second object was accelerating down. So if it is accelerating down, it means that W2 is more than the tension. So I can say that W2 is greater than the tension. So W2 is more than tension and it is equals to resultant force according to Newton's second law. But because the mass of this object was M2, so we wrote M2A. Now, if we want to write a combined equation, how to write a combined equation? For acceleration, we just add them. So if I add the two equations, Like this is equation 1 and this is equation 2. I just add them. So I can write it here, like I can write T1 minus W1 plus W2 minus T is equals to M1A plus M2A. So this T will cancel with T and it will be W2 minus W1 because one is positive, and if this will be M1A plus M2A. Here weight is mass multiplied by gravity. So W2 will be equals to M2G and W1 will be equals to M1G. And that is, if we take A common from here, it will be M1 plus M2 into A. If we take G common from this, so this will become M2 minus M1 into G divided by this whole factor M1 plus M2. So using this formula, when two objects are accelerating vertically, I can work out the expression by directly using a formula, which is M2 minus M1, the difference of the masses, the greater mass minus smaller mass, divided by the sum of the masses into gravity. But again, as I mentioned, I don't want you to memorize these formulas. I don't want you to memorize this formula. Just understand the concept that whenever object accelerate, the resultant force is always equals to ma. Same way, if an object is, one of the object is on the horizontal surface and the other object is moving vertically and it is accelerating downward, if it is accelerating downward and here's the tension T is there, so what will the equation, the first equation we can write W2 because it is second, so we can write W2 minus T is equals to M2A. And what about this object? Because this tension will be T here. And if there is no friction, like the friction of the surface is negligible. So for the second object, we can say T, the tension is equals to M1A. Why? There is no force subtracted because there is no force to oppose the motion. So the first object, W2 minus T is equals to M2A. The second, the second object, W2 minus T is M2A. The first object, T is equals to M1A. Again, if I need an acceleration of these two, the combined acceleration, because they will have the same acceleration, I need the total acceleration. So how we can work out? We can just simply work out by adding the two equations. If I add them, it will be W2 minus T plus T is equals to M2A plus M1A. T will cancel with T. So W2 is equals to M2 plus M1 into A. W2 is M2. G is equals to M2 plus M1A. And if I need the acceleration, so simply we'll divide. So M2 is divided by M2 plus M1 into G is equals to A. So that's a direct formula. If we want the acceleration of two objects, which are, one is on the vertical plane, like attached with a pulley, another one horizontally attached with a pulley, moving on the horizontal surface with no friction, we can, if we know their masses, we can work out the acceleration directly. So that's a direct formula, but no need to learn. Just try to understand how we can work out the acceleration. Just adding the two separate equations, you will work out the acceleration. Wouldn't the weight be half due to the pulley system? No, it depends on, the weight will not be half. If you attach two objects and they have different weights like W1 and W2, so this will be tension T will be there and this will be the tension T to pull the object. In a force multiplier, when you use two pulleys, then the weight will become half. But in a single pulley, the weight is same as the tension. When we use two pulleys, the weight will become half. As one of the student asked, that about like would the weight be half? Weight is half when two pulley systems are used. When we use two pulleys to balance out, in that case, the weight will become half. Now, motion in a lift. The motion in a lift, it depends on which direction the lift is moving and what is the state of the motion. For example, a person is standing and the lift is initially stationary at rest. Or, so what are the forces acting on the lift, on the person? The resultant force should be zero because it is at rest. The weight of the person is acting downward and the normal contact force will act upward. So weight is acting downward and the normal contact force is acting upward. So what I can say here, because it is stationary, or if it was moving at a constant speed, so both cases, what will happen if object is stationary or moving at a constant speed? In that case, the weight minus the normal contact force is equals to 0, or weight is equals to R. Means the normal contact force will be same as the weight of the person. So if the weight of the person appear to be 700 Newton, the normal contact force is also 700 Newton. When the lift is stationary or it is moving at a constant speed, that's the first case. Is it clear, the first part?
Yes.
But what will happen if the lift is accelerating upward, like going upward? So lift is accelerating upward. First, what are the forces acting? The forces acting is the weight of the person and the normal contact force. Because the lift is accelerating upward, so the acceleration of the person should be same as the acceleration of the lift. So both should have the same acceleration. What will happen in this case when I write the equation? Which force should be greater? R or W? If the lift is accelerating upward, person is going upward. So R should increase. Yeah. So I will write R minus W is equals to MA. Why MA? Because there is a resultant force. And so R is equals to W plus MA. So if R is equals to W plus MA, means the value of the normal contact force will increase. If the value of the normal contact force increases, what does it mean? It means the downward force should be greater as well. So this is called the apparent weight. So when the lift is accelerating upward, you will feel that you are heavier. Why you will feel you're heavier? Because if the normal contact force, like your weight is 700 Newton, but because to accelerate upward, the normal contact force should be higher. So the normal contact force should be, like example, 900 Newton. So how much extra downward force will be there? Because the normal contact force is a reaction force. So how much total extra downward force will be there? So extra 200 Newton downward force will be there. As a result of this extra 200 downward force, what will happen? You will feel heavier. Whenever object accelerate upward or the lift accelerate upward, you will feel that your weight has increased. And this is not the actual weight. This is called the apparent weight. Yeah, the question is why there is a 200 Newton downward force. So what actually happened is, yeah, I will come to that point. Say, yeah, I understand this is a very common question, like how the force is downward. Say you're in the lift. So you're in the lift and you have a weight of 700 Newton and there's a normal contact force of 700 Newton. Okay. And the lift is stationary at rest or it is moving at a constant speed. So what will happen? A 700 Newton here and a 700 Newton here, the forces are balanced. And if you consider the earth, and say the lift is moving, the earth is pulling you by a force of 700 Newton. That's your weight, and you will also pull the earth by a same force in opposite direction. Now the second example, if we say the lift is accelerating upward, so if the lift is accelerating upward, what you need a resultant force upward. So if you need a resultant force upward, what will happen to the normal contact force? The normal contact force is 700 Newton. So actually, when the lift is accelerating upward, because of your inertia, as the lift is accelerating upward, because what is the tendency of a body? Tendency of a body is to resist the change in state. So you don't try to change the state. So the body is having a mass, and because of the mass of the body, the inertia of the body, there is an extra downward force. The extra push is there downward. So when the lift is accelerating upward, the body, because of its inertia, apply a downward force, extra downward force of 200 Newton. Example. So as a result, what will happen? Now there will be a normal contact force. What will the normal contact force? Because the weight was 700 and because of your inertia, you try to push the ground with a force of 200 Newton. So what is the total downward force? The total downward force is 900 Newton. So if the total downward force is 900 Newton, what will be the total upward force? The total upward force will also be 900 Newton. And when the total upward force is 900 Newtons and the force of the gravity, the weight is 700 Newton. So with reference to the earth, you are accelerating. So because in the lift, you are stationary. In the lift, you are not moving. In the lift, you are at rest. So when you are at rest within the lift, what should be the resultant force on you? The resultant force on you should be zero. But if someone is looking for you from outside and observing the lift, according to him, you are accelerating. And your acceleration is same as the acceleration of the lift. So what actually happened that when the lift is accelerating upward, our body is having a mass, and because of the mass, we have inertia. And because of the inertia, we tend to resist the change. So if the lift is going up, accelerating up, we try to resist the change. To resist the change, naturally, our body will apply a downward force. When naturally our body will apply a downward force, so the total downward force is now the weight plus the additional downward force. So normal Newton, according to Newton planar forces, what will be the contact force? The contact force is also 900 Newton. But this 900 Newton, the contact force is more than your weight with reference to the earth. So that's why you're accelerating with reference to the earth. So the frame of the reference within the lift, you're stationary. That's why the total downward force must be equal to total upward force. But with reference to the earth, you're accelerating. So how you're accelerating? Because the upward force is the total upward force or the normal contact force is actually greater than the total downward force, like the gravitational pull, not the total downward force, the gravitational pull. That's why you will accelerate upward. Is it clear now? Anyone having a doubt or a question about this? So actually what happened? So actually what happened is the tendency of a body to push, to remain in inertia, and that is not your actual weight. Like the reading on the balance will appear higher than actual. If you're standing on the scale, like here he's standing, here he's standing on the scale, so the weight is acting downward and the normal contact force is acting upward. And if the weight is 700 Newton, the normal contact force will also be 700 Newton. So the normal contact force and the weight are equal in this case. So the reading on the balance will be 700. So just remember the concept that whenever the value of the normal contact force increases, the weight will also, this is called the apparent weight, not the actual weight. Like you will feel heavier. And you can experience this thing, like you use a scale, a balance, attach any object to that balance and enter the lift and move to the from the ground floor to the top floor. You will find that the reading on the balance will change. It will increase. So whenever a lift is accelerating upward, the weight is acting downward, the normal contact force is acting upward. The normal contact force is more than the weight, so that is equals to ma, or normal contact force will be equals to W plus ma. Means the normal contact force will be more than the actual weight, because weight plus the ma, so normal contact force will be greater than the actual weight. And if the normal contact force is increasing, it means it appears that the downward, because the normal contact force is a reaction force, so it means the downward force is also increasing. That's why whenever the lift is accelerating upward, you will feel heavier than the normal. Is it clear, this example? Any doubt in this? Then what will happen if the lift is accelerating downward? So if the lift is accelerating downward, so the forces which are acting, the weight is acting downward and a normal contact force is acting upward. Which force? So it means because it is accelerating downward, it means the weight must be more than the normal contact force, and that is equals to ma. And we can say, what about the normal contact force? So W minus ma is equals to R. So the normal contact force will decrease. If the normal contact force will decrease, the weight will also appear to decrease. It's not like, this is called the apparent weight. But how we explain in terms of comparing the motion? See, you're in the lift, and originally the lift is stationary at rest. Weight is acting downward, the normal contact force is acting upward. For example, the weight is 700 Newton, the normal contact force will also be 700 Newton. Now what happened? The lift is accelerating downward. If lift is accelerating downward, what will be the natural tendency of a body? Inertia. Inertia try to resist the change. Which direction the body will try to apply a force? To resist the change because of the inertia. Which direction the body will try to apply a force? To resist the change, the body will try to apply a force in upward direction. That's right. So, so what actually happened, like example, if a body apply an upward force of 100 Newton. So as a result, what will happen? The total force, because this was a reaction force when the object was at rest. But if the object is stationary, so if the object is accelerating down, so if the object is accelerating downward, our weight is 700 Newton, but because of our inertia, we always try to resist the change. So what we try to do, our body will try to resist the change. How it will try to resist the change? By applying a force in opposite direction. So example, if body try to minimize the force, apply a force of 100 Newton. What is the total downward force here? What is the total downward force? No. The weight is 700 and the body try to apply a force because of the inertia 100, what is the total downward force? So the total downward force will be 600 Newton. So if the total downward force is 600 Newton, what will be the normal contact force? The normal contact force will also be 600 Newton. So means the normal contact force appear to be decreased. If the normal contact force appear to decrease, what does it mean? The object will feel lighter. In this the example in which the object was accelerating, if it was accelerating upward, the weight was 700 newtons. The weight of 700 Newton, because of the inertia, the body try to resist the change. So body will apply, example, another 200 Newton downward. So what is the total downward force on the ground? The total downward force on the ground is 900 Newton. So the total upward force from the ground should also be 900 Newton. So if the reaction force increases, so whenever object is accelerating up, the normal contact force increases. When the object is accelerating downward, the normal contact force will decrease. If the normal contact force increase, it means the downward force is also greater. That's why we will feel heavy. But when the normal contact force decreases, the total downward force is also smaller magnitude. That's why the object will appear lighter. So when the lift is going down, you will feel lighter. When the lift is going up, you will feel heavier. Is it clear? Any question or doubt till this point about the motion in the lift? So when the object is accelerating downward, if object is accelerating downward, what is the tendency of the body? The tendency of the body to resist the change. So because of your inertia, you try to oppose the change. So your weight is downward, which is 700 Newton, and you try to resist the change, example, with a force of 100 Newton. So what is the net force on the ground? The net force on the ground will be 600 Newton. So net force on the ground is 600 Newton. The net force by the ground will also be 600 Newton. So the normal contact force appear to decrease. Reaction force is only produced because of the action force. So first there should be an action force, then only there will be a reaction force. If there is no action force, there will be no reaction force. For example, if the lift, if it breaks the cord and the lift is moving a free fall. For example, if this lift is falling and same as the acceleration due to gravity. So what will happen in that case? If we draw an arrow, the weight is acting downward, the normal contact force is acting upward. So I can say R minus W minus R. W minus R is equals to MA. Or I can say W minus MA is equals to R. But acceleration is due to gravity, so I can say W minus mg is equals to R. And weight is mass multiplied by gravity, so I can say mg minus mg is equals to R. So they both cancel out. What is the normal contact force? In that case, the normal contact force will be 0. So it means in that case, the object will not experience any force at all. So what does it mean? It means, see, this is object is accelerating downward. The object is accelerating downward and it has the same acceleration due to gravity. So weight of the person is example 700 Newton, and because of the inertia, when the object is falling, same as the acceleration due to gravity, because of the inertia, the object also have the same force as a weight. So what is the result of these two? The result of these two forces is zero. If the resultant force is zero, what is about the contact force? The contact force will also be zero. Contact force produced, it depends on the total downward force or total upward force. So when object is falling because of the gravity, same as acceleration due to gravity, the force due to inertia is same as the force because of the weight, and they cancel out each other. So the object does not apply any downward force. If it does not apply any downward force, the object will have no like it will not feel the weight, or we call that as a weightlessness. I'll continue this part, the explanation, join from the other link.